Hi, and welcome to the video on graphs of rational functions. So we're just going to look at their graphs, and then we're going to also find their characteristics or find rational functions based on characteristics. So let's jump in and get started with these. All right, so there are 6 main characteristics that we need to check in all rational functions. Those are wholes, or removable discontinuities, domain and vertical asymptotes, which would go hand in hand, all the intercepts, the horizontal asymptote, in behavior, and graphing with Desmos. So those are all the topics that we're going to go over. All right, so let's look at this first example. The first thing we're going to check for is wholes. And remember, wholes occur where the denominator and the numerator equals 0. So let's check the factors. The numerator has factors of x minus 3 and x plus 2, and the denominator has factors of x minus 7 and x plus 8. So there's no repeated factors, so there's not going to be a place where the numerator and the denominator both equal 0. So the first thing we can just write down is no wholes in this one. No wholes. All right, let's go ahead and find the domain and the vertical asymptotes. Where do we do to find that? All right, so we look at the denominator, right? And we're going to set for x minus 7, x plus 8, all nice and factored for us, equal to 0 to find the domain and what to exclude from the domain and what the vertical asymptotes are. So this first factor is 0 when x is 7, and the second one is 0 when x is negative 8. So my domain is minus infinity to minus 8, minus 8 to 7, and 7 to infinity. It's a little union sign there. All right, so that's my domain, and that means my vertical asymptotes are x equal to 7, a line, vertical line, and x equal to negative 8. All right, great. 2's done. Check wholes, check domain and vertical asymptotes. All my intercepts. All right, let's go ahead and check those. So those are going to happen when my numerator equals 0. So to find my horizontal intercepts, I'm going to set my numerator equal to 0. Horizontal intercepts. So that's where 3x minus 3, x plus 2 equals 0. So those are going to happen at x equal to 3 and x equal to negative 2. So those are going to be 3, 0, and negative 2, 0. And my vertical intercept is going to happen where at f of 0. That's always true. So my vertical intercept is f at 0, which is 3, 0 minus 3, 0 plus 2 over 4, 0 minus 7, 0 plus 8. So we have to do some multiplying here. So that's 3 times negative 3 times 2. Be careful because it's really easy to miss a minus sign here. 4, negative 7, and 8. So the numerator is 3 times negative 3, which is negative 9, times 2, which is negative 18. And the denominator is negative 28 times 8, which I don't actually know off the top of my head. So let me just really quickly. It's 224. Negative 224. And is that divisible by 8? 18? Nope, it's not. So negative 18 over 224, let's reduce that fraction so it's a little easier to work with. Well, I know 2 goes into both of those. So I'm going to make that be, well, first of all, let's do that. Because the numerator and the denominator are both negative, it becomes a positive number. And then 2 goes into that, so that's 9. And this is 112. And I don't think that's it, because 9 is only divisible by 3, and 112 is not divisible by 3. So I think that might be all we can reduce. So 9 over 112. I'm trying to use my calculator here, and I'm having some issues here. Okay. All right, so that is my vertical intercept, 9 over 112. And now, so that's 3 done. Check. All my intercepts are found. Well, let's go ahead and write that as an intercept. That'll be good. So my vertical intercept is over 0. up 9 over 112. My horizontal asymptote, okay, so this is the one that has those rules, right? And the rules regarding the degree of the numerator and the degree of the denominator. Now, when it's all factored out like this, it's a little bit harder to find degree, but we know that this is a quadratic in the numerator and also a quadratic in the denominator. So that's going to be degree 2 for both of them. So when the degree of the numerator is the same as the degree of the denominator, then the ratio of the leading coefficients is your horizontal asymptote. So in this case, that's going to be 3 over 4. So our horizontal asymptote is y equals 3 over 4. All right, so we got that one done. Check. So what's going to happen in the end behavior? Well, it's going to go to the horizontal asymptote 3/4. And so let's go ahead and graph this with Desmos. All right, my function is 3x minus 3x plus 2. And I want to put parentheses around the numerator. 3x minus 3x plus 2 divided by, and now I put parentheses around the denominator too, just to be careful, 4x minus 7x plus 8. All right, and so there is my rational function. You can see that, let's find all the features that we had. The first features we found were no holes and vertical asymptotes at 7 and 8. I kind of like to just graph them in there. So if I just write x equals 7, and then you can even make it a dashed line if you want to be super fancy, which I kind of do. Let's see if I can make that happen. I know if I hit this, oh, there we go, dashed line. There is my x equals 7, and then I can also do x equals -8. All right, so there's my graph with my vertical asymptotes, and that looks really good from what I found algebraically. And my horizontal intercept was at -3 and +3 and -2. So let's zoom in there just a little bit. I think let's do that kind of thing. And there we have 3, 0, and -2, 0. So that looks great. Mark those guys down and add labels. And then my vertical intercept was at 0, 9 over 112. It's very small, but there it is. It's not going to have a fraction for me. It's just going to, let's see if I can make it be right on 0. I'm not having a lot of, so close. Let's see if I can zoom in a little bit more. There we go. And so there's my vertical intercept, great. And finally, we have my horizontal asymptote at y equals 3/4. So let's go ahead and put that in. Y equals 3/4. And let's make that a dashed line too, because I like that for horizontal asymptotes, or just asymptotes in general. And then let's close this up, and this is my graph, and it looks pretty good, right? And those are all the characteristics we found, and now we are looking at the graph. All right, so what I want you guys to do now is I want you to pause the video and do all those things again with this new function. All right? All right, how did it go? Well, let's go ahead and get started. The first thing I'm going to do is I'm going to factor the numerator and denominator to make my life a little bit easier. And the numerator has a greatest common factor of x, so that becomes x times x minus 5. And the denominator also has a common factor of x, so that's x times x squared minus 3x minus 4. I can factor more. X minus 5 is my numerator. X minus 4, x plus 1 is my denominator. Multiply to -4, add to -3. Great. All right, so are there any holes? Is there any common factors in the numerator and denominator? Yes. When x is 0, we get 0 over 0. So there is a hole at x equal to 0. All right. Let's talk about the domain. let's set the denominator equal to 0 and figure out what's not in the domain. So x minus 4, x plus 1 equals 0. So that's going to happen at x equal to 0. Well, we know we have a hole there, so we knew that wasn't in the domain. X equal to 4 and x equal to negative 1. So those are all values not in my domain. So my domain is going to be minus infinity up to negative 1, negative 1 to 0, 0 to 4, 4 to infinity. A lot of pieces for that guy. And so I also know my vertical asymptotes, which are here at x equal to 4 and x equal to negative 1. There's not going to be a horizontal asymptote at 0 because that's going to be the hole. I forgot what my third thing was. Oh, horizontal, all intercepts. Okay, let's find my intercepts. So to find where the numerator equals 0, that's x times x minus 5 equals 0. Again, the x equal to 0, that's a hole, so that's not going to be a horizontal intercept. But x equal to 5 will be 1, so that's over 5 up 0. And our vertical intercept is going to be at g of 0, which we already know has a big problem, right? It's 0, 0 minus 5 over 0, 0 minus 4, 0 plus 1, but it doesn't matter because this is just 0 over 0, which is undefined. So that means it has no vertical intercept. All right, what else do we need to find? So we found a horizontal and a vertical intercepts, a horizontal asymptote. So we need to think about the degrees. So the degree of the numerator is 2. The degree of the denominator is 3. So there's a bigger degree in the denominator, so that means y equals 0 is the horizontal asymptote. Five is in behavior, which I'm just going to look at on the graph of Desmos. We don't really need to do anything with that. So let's go ahead and graph this on Desmos and see if we can see all these cool characteristics. All right, so let's open up Desmos and do this. All right, let's graph our function. All right, let's graph our function. G of x equals x squared minus 5x. Start with that. G of x equals x squared minus 5x divided by x cubed minus 3x squared minus 4x. X cubed minus 3x squared minus 4x. Let's just double check that I got that right. X cubed minus 3x squared minus 4x. Yes, I did. Okay, so there's my function. It looks pretty good. Let's go ahead and put in all the things that we found. So we found vertical asymptotes at 4, or let's talk about the hole at x equal to 0. Let's see if we can see it. Zoom in there. Look here at 0. If you actually it says 0 is undefined. See, there's my hole. That's what that looks like on Desmos when you graph a rational function that has a hole in it. And then let's put in our vertical asymptotes, which are at I think 3 and 4. 4 and negative 1. And let's make those dashed lines. See how those look. Let's zoom out quite a bit. Yeah, that looks pretty good. And let's go ahead and put in our horizontal intercept at 5, 0. Let's see if we can find that. Looks like right there. And we had the hole, so we have no vertical intercepts. And we have the last thing as our horizontal asymptote at y equal to 0. And there we go. Looks good. Now I want to point out in this graph, it does actually cross the horizontal asymptote right here. right? So you can cross horizontal asymptotes. You can't cross vertical asymptotes. But what is happening with the horizontal asymptote is what's important with it is what happens in the long run. And when that means like in behavior. So even though we cross it here in the end, it's heading towards 0, both as x gets really big and as x gets really small. All right, so what we're going to work on now is finding a rational function that has specific characteristics. So kind of going backwards from what we have been doing. So the first thing we're interested in is going to give us a bunch of information. So we want a rational function that has vertical asymptotes at x equals 1 and x equal to 4. We want it to have intercepts at -2 and 3. And we want to have a horizontal asymptote at y equal to 0. So let's see if we can build up this rational function. I'm just going to call it r of x. If we wanted to have vertical asymptotes at x equal to 1 and x equal to 4, the denominator needs to be 0 in those places. So I'm going to make it x minus 1, x minus 4, right? That will make it have vertical asymptotes at 1 and 4. If we want, so that's done. Check. If we wanted to have x-intercepts or horizontal intercepts at -2 and 0, I'm going to make this be x plus 2, x minus 3. So when I plug in -2 and I plug in 3, did I say 0? When I plug in -2 and I plug in 3, it'll make the function equal to 0. Great. And the final step is to make the horizontal asymptote at y equal to 0. Well, how do we have a horizontal asymptote of y equal to 0? When does that happen? Okay. That happens when the degree in the numerator is smaller than the degree in the denominator. So that means the numerator degree is less than the denominator degree. Well, as we have it right now, our numerator is degree 2 and our denominator is degree 2. Those are both quadratics. So we can't have that. We won't have a horizontal asymptote at 0. So the way we fix that is we just make the degree of the denominator bigger. So I'm just going to add an x right down here. You could add x minus 5. You could add whatever you want. I'm just going to add an x. The only thing you could not add is x plus 2 or x minus 3 because that would mess up your horizontal, your x-intercepts, right? You can't add a factor that's in the numerator because that would make a hole. But other than that, you can just put any factor that you want. So there enough, we have our rational function with the given characteristics. All right, and our final example for today is this rational function, and we want to find its graph. So let's see what we can do here. Let's look and see what we have on this rational function. Well, I can see on this rational function that it appears to have a vertical asymptote at x equal to 2, and also at x equal to -1. Okay, so if I'm trying to build up this function, I'm going to start with that. So that means my denominator is x minus 2x plus 1. All right, what else do we have on this function that we can spot? Well, I can see it crosses the x-axis at 3 and at -2. So I know this has to be x plus 2, x minus 3. All right. Finally, I can see, let me use green, actually I use blue. It looks like it has also a horizontal asymptote here. At 2, at y equal to 2, but also, I forgot about this one, it looks like it also has a vertical asymptote, a vertical intercept at 0.6. So I'm actually going to do that one first. So let's go ahead and work on the vertical asymptote first, and then we'll see what happens with the horizontal asymptote. So the way I find that is I'm just going to put an a in here since I don't know what that coefficient is, and I know that r of 0 has to be equal to 6 because the point 0.6 is on the graph. So that means that a times 0 plus 2 times 0 minus 3 over 0 minus 2 over 0 plus 1 has got to be equal to 6. So that tells me, oh, I have a little more space down here. I do, good. 6 equals a times, well, this is 2 and -3, so that's -6. And this is -2 and 1, so that's -2. So 6 equals a times 3. So that means a equals 2. So I can come back up here to my rational function and be 2, x plus 2, x minus 3, over x minus 2, x plus 1. And that solves my the problem with matching the vertical intercept, but it also solves a problem with my horizontal asymptote because we can see the ratio of the leading coefficients. This is a 1 if nothing is written down, right? The ratio of the leading coefficients are 2 to 1, which is exactly what we have up here as our horizontal asymptote of y equal to 2, because the degree of both of these is both 2. So we found the function for that graph, and that's the last of this video.